Okay, so let's I make this a little bit of data up. Okay. Now this is completely made up. This is completely made up. Oops. Oops. I'm missing a bracket or something. Oh, okay. For some reason, I just entered it. Okay, right. Okay, so I'm just making this data up. Okay, let's say this is a very good model. This is x1. This is x2. This is x1. This is x2, and this is y. This is a good model. Okay, so it's a model of something. I ask you. Okay, you're standing right here, standing at this one point. Okay, standing at this one point. What is the contribution of x1? Okay, what makes you stand here? It's the same question, right? Second question, right? Now I have here x1, 2, 3, 4, but obviously, you know, for the plotting purpose, I'm going to give you an example of y is equal to f x1 x2. Okay. Yeah. So let's look at this. Okay. Now I'm standing at x star. This is my x star. What makes me stand there? Okay. Obviously, the reason I'm standing there is because that's the value of x1 and that's the value of x2, right? Right? Yeah, because after all, I create the function. I just make this function. I have two test functions just so that you can play with it. Okay, let's say I'm looking at this function. Okay. Maybe inverse of that. Nicer. I don't know. Yeah. Okay, so I'm standing here. I'm standing here at x star. What is the influence of x1? Okay. What's the influence? What makes me stand at this value? Well, now this is very important. The data is not distributed universally from x1 to minus infinity to x plus infinity. It actually covers this data distribution. Okay, so it's actually, if you look on top, it's actually an oval. This is actually an oval. Okay, it got trimmed a little bit, but it's actually an oval. Okay, so it's actually an oval, right? So you have this data, okay, x1 here, x2 here. What makes this point special? For this point, what makes what's the contribution of x1? Well, I can do it two things, like I said. The dumb thing is to say, well, let's take all the other points and take the difference. That would be here. Take the dumb point, right? The dumb way would be this. Okay. Take all the other points, okay, and find the difference from that point. Okay. So all it is just to say that the average height is different from that. That's dumb because that takes into account all the variables. Okay, that takes into account all variables. So let's not be dumb. Let's be smart, like economists. What economists would do in this case, similar thinking, would be take all this, fix value of x2. So make a slice here, x2, and then vary x1. Okay, that's what it means. Ceteris paribus, right? Keep x2 constant and vary all the x1. Okay, so basically you sample x1 from all our other point. Notice what happened here. As you sample x1 from other point, let's say you sample from here, you actually assuming that it is possible to have x1 here and x2 here. That's not possible. That's way outside your data set, right? This is what I mean by economists being silly when they move this really far. You can only do that for just a tiny neighborhood around the point. If you go very far, in this case, here, you get nonsense because the data point here doesn't exist. Okay, so that's what I mean by this is called like partial dependence plot or something like that. People do that. And that's the same thing. People who do partial dependence plot are silly in the same way that economists use ceteris paribus without get carried away with it. Okay, so if I'm going to sample all the x1 and x1 goes from here to there, but keep x2 constant, I'm going to end up with a lot of things here, which is nonsense. This is silly. This never happens. All right. So what happened is same thing. Remember the game theory? You have two extremes, right? Calculate individual impact by assuming everybody's the same and you're there, you're not. Or just comparing two different data sets. They're both silly. So what the Shapley method do is to use Shapley value. The Shapley value is a hybrid of this extreme. But instead of taking all the points being different, or just the point you are interested in being different, it takes a subset of points being different. So for example, let's say I have x1, x2, and x3, and say x4, right? I take what's called random permutation. In mathematics, this is easy to do. This is basically a subset. Okay? Now, if I'm interested in x1, I look at this and say, oh, let's say take this one. It has x4 in it. Okay, let's look at that one. So let's say it has x4. Okay? So what I do then is I do this. Take, but instead of just moving x1, you also move x4 as well. Okay? Okay? You move x4 as well. Okay. So when you did this, it's sort of like a halfway. This is sort of like a middle ground, except you do this randomly. So the Shapley value of x star, x1 star, contribution to x star is the average of all of this. Okay, so you do this, and you do so it's a combination. Now, if you want to look at the details, I strongly encourage you to look at these two very good tutorial. This is a good tutorial, and this is a very good videos. In fact, I just watched it this morning. Okay, it's a very good video for explaining how Shapley value is. So what Shapley value, in other words, by the way, this is two different Shapley here. This Shapley is SHAP capital. It's derived from Shapley. So it's called Shapley additive explanation. So Shap value of, so I should say Shap value. Okay, Shap value of this is a contribution. Okay. Now, if I want to know x1 versus x2, x3, what I can do is take all the Shap. This is only Shap value at x star, right? This is only at x and y star. So do this for all the y's. Do this for all the y's and all the x, and then you do what's called Shap plot. So Shap plot. Let me see if I can find it on the internet. Yeah. Now it's going to look like this. Okay. Oops. So if, okay, if I take the individual sharp values for all the points for each explanatory variable, and I take the average of the absolute, because I don't care about direction now. Let's say I don't care about direction. It would turn out that for this model, alcohol is the most important variable. Sulfate is the second most important variable. By important, it means it pushes the model. Okay, so you can think of it as if there's no model, hold on, where's the bits and pieces? If there's no model, this is a flat line. This is a flat line. Because there's a model, there's a variation in y. Variation in y is due to x1 and x2. To determine how important x1 is, I look at each point and see how it pushes to that value. So that's the sharp value of x1 for that point. Now I take the average of the absolute value of all the sharp values. So I get this. Okay. Now, obviously, in this case, I only have two variables, right? But in reality, it will be like, like this, 20 variables. So in algorithm, in Mathematica and in Python, this is now a standard. Okay, it's now a standard. So it does both. It does look at now. So you can look at direction as well. So if I don't take the absolute value, you can see that it pushes to the right and pushes to the left. In this case, I think something like whatever, I don't know what the output is, but in this case, it will be something like the lower the alcohol, the higher the Y. But the higher the alcohol, the lower the Y. Whereas this thing is the opposite. The higher the volatile acidity, the higher the Y. Because the blue and the red is a different direction. Okay. But either way, you can see that when you take the absolute value and average, this thing is much larger. The influence is big. So this distinguish between direction of influence from positive, in other words, more of this, more of x1, more of y1, more of x1, more of y, or more of x1, less of y. So direction of causation, right? Positively or negatively correlated in that sense. Okay. Except this is done in a way that does not assume linear model. So it's a completely generalized way of doing things. And you can do this with neural network. You can do this with decision tree. You can do this with everything. Okay. Now, with linear regression, you obviously can do something else easier, right? That's the standardized coefficient, right? So I think I put the note here. If for linear regression, you can do what's called a standardized coefficient. But this case, you can do for anything in general. What's called model agnostic. Okay. Agnostic means doesn't care. This chap value, this chap plot works for anything. This thing is not model agnostic because it only works for linear regression. You should review that, by the way. This is good. I like this article. It's written well. It warns you a lesson. Okay. So if you can, okay, if you can, and you understand what this thing is, your project too should produce a sharp plot. Okay, because it's going to explain like this. So maybe this one is in Thai. Okay. So this is very good, but this is reference to Python code, okay? But for Mathematica, you have to go to, again, performance measurement. Shapley is in here somewhere. So it's in here somewhere. Sharp values. Oops. Shapley additive feature. So SHAP, additive explanation. Okay, there are other ways, by the way. Line, for example, line, I think stand for locally something. Local something something. I forgot. Ah, there it is. Local interpretable explanation. Local L, interpretable model agnostic. I should make this small a. Okay. So this, but I prefer Shapley. Okay. In fact, I don't know. I'm not really sure how line works. Okay. So that's it. That's a very important insight. So you know, you build the model that learns. Even if, by the way, even if your model is linear regression, you can still use this, right? But of course, it'd be a bit silly because with linear regression, you can do standardized coefficient. Let's see, where's that? Is that the right link? Yeah, right. That's it. That's it. Okay. So you look at the coefficient of a standardized regression. Okay. And that brings you back to pre-processing because it has standardization. Okay. So we talk about the importance of this thing, making sure that you're developing a model with a training, but you don't cheat because you're testing against the data it hasn't seen. So you know that it's fitting well, but it's also generalizing well and so forth. And then in the post machine learning analysis, you look at, you know, how well it's doing against that testing, but you also try to do something else, like just take into account how the model works. Okay. Again, a good thing would be something like a good test exam question would be, what would be a not model agnostic way of explaining how things work in linear regression? Then you say, okay, well, just look at coefficient. Or decision tree, you can look at the node, right? The breast cancer data, why is it doing this? Oh, because this value is higher than this, and so it does that, and so forth, okay? So some models are easier to dissect. Decision tree, easier to dissect. Linear regression, easy to dissect, okay? Neural network, not easy to dissect, but you can do this kind of test. What happened when the value of x1 is different by sampling from other places? And you can estimate this, and this is called Shap plot, okay? Shap plot or Shap graph, I'm not quite sure, I forget. I think it's Shap plot. I'm not sure. Shap, I think it's Shap plot, okay. Shap plot has 1 million hits. Shap graph has 4 million. Oh, Shap graph. Hold on, let me put in double quotation to see which one's more popular. Shap graph. Shap. Oh, that's not good. See? Shap. Oh, Shap graph. Shap graph is not good, but Shap plot. Yeah, Shap plot. So use Shap plot. So it's going to look like this. Again, the color sort of like indicates a direction, whereas the width indicates how much it pushes, okay? Shap plot. Okay. So I would really want to have this as part of your project, okay? Now, obviously, if you're doing cluster analysis, this doesn't really belong because this is about how explanatory variable pushes the value of y. Okay. Right. So this pre-processing, I think I may have mentioned a little bit last time, basically scaling versus normalization and let's say scaling. Scaling. This is where you take all the x, right? The only thing I want to say instead of x, say I, use xi minus mean of xi divided by standard deviation of xi. That's what it means. Now, note that when you have in sample out sample split, okay, this becomes means of xi in sample. Okay. Why? Because your scaling has to be from the data that you can manage. So this scaling factor, this mean, the standard deviation is taken from your in sample. But when you test it, you apply to everything. Okay, that's something very important. Now, there's a reason why you would use it, because you don't want xi to dominate xj. That's basically it. Okay, why not? Why not? Because sometimes, because you don't need to. Or if their means and standard aren't that different, it's easier to interpret and scale. Okay, why not? And also neural network kind of just for it. So, okay, principal component analysis. I'm just going to mention briefly because I want to spend time with your project. The two cases you would use as a dimensionality reduction. We talked about that, right? For example, x all the way n, x1 n to z1, because it's not x anymore, zn, where n is much less than. Okay, so that is not just one thing, because you can use that with other tools of dimensionality reduction. More importantly, moreover, as a tool for concentrating variability. In other words, if you have this thing, okay, changes, z1 has more variability. Z1 has more variability than Z2. Okay? And so in other words, it takes into account all the movement of the input. And I mentioned that example of the yield curve, I think last time. I'm just going to draw a quick picture, right? So a yield curve is something that looks like this. Okay, oops. Something that looks like this. Oops. Okay, and maybe it moves to here. Okay, but the main movement is one parallel shift. The other movement is some kind of change of slope. Then the other kind of movement is this. This thing matters first. This thing matters second. This thing matters third. Okay, so instead of having all the movement, you just say, okay, well, this thing happens. Most of the movement is a parallel shift, and a little bit of sharpening, okay, and so forth. Moving average filter equates the, I wanted to mention a few words about this thing called feature engineering. I really don't really like this very much because this is where you kind of meddle the data science process. A lot of professional data scientists spend inordinate amount of time doing feature engineering. I do too. Not because I want to, but because sometimes due to the limitation of the project, I have to. Okay, but in general, this kind of twiddling with the input is a little bit it's not that productive. But anyway, I'm not going to talk about that. So finally, and this is a cliffhanger, this is going to be important for next class. You can think of moving average filter as performing some kind of filter. So in other words, instead of using X1 back 10 period, you just take an average and a moving window. So that's kind of like a processing. That processing is not learned. That processing is, again, feature engineering is not a machine learning process. Precursor to it. Okay. Cursor, how do you say that? Yeah, precursor to it. Okay. Now, so filtering is not learned. Machine learning is learned because you use the data to tune it. Use data to tune ML parameter. So filter parameter are static. Constant. Okay. So this is the important thing. Okay. When you're talking about feature engineering, it's about doing some kind of predetermined filter, playing with the filter, moving average, exponential moving average, linear moving average, Bollinger Band, this, that. Okay, you just manage your data and then you feed to machine learning. But the filtering has parameters that are not learned, like moving average, how many periods to go back, that's a parameter. Okay, exponential, what's the lag parameter, what's the lag coefficient, lag rate, those are parameters, they're not learned. That's very important. So this is how it's done. Keep this in mind for next class. Okay, I won't tell you what it is, but you see that next class. So keep this in mind. Okay, so that's it. I think I've used up my time. I have 40 minutes left for supervising the project. So I'm going to save this. Okay, this thing I'll save as well, although it's not that important. Okay, you can play with this. It's not really important. Subset, or this is the example I was going to give, say subset. Okay, so let me, before I forget, let me just go to your line group and add this, add the class material document, okay? It's word 1, 2, 3, keep speed, okay, good. A second. Okay, so you have that, okay, and you still have the machine learning notes. I think I don't know if I update anymore, but I'll just give it to you just to be on the safe side. Supervised learning. I think you already have this. Okay. Okay. Good. Now, let's go to students. And students are okay. Come, let me stop sharing now and go to Sivaratin,วงเจริญศิลป์ศิวรัตน์ค่ะ ศิวรัตน์ค่ะ สวัสดีค่ะมาให้ลูก
สวัสดีค่ะ
Okay, you have the screen. Okay.
Hold on.
Okay, I'll let you share the screen. And yeah, I'm very good at keeping time today because I actually have the clock. Okay, I'm not sharing the screen anymore. So you have the screen. Not yet. I don't see that. Can you?
I have to quit Zoom and then join again to share the screen.
Notเห็นไหมลูก
ไม่เห็น if you have
I
to
have
quit okay you can
I
do
have-
it I will accept you
this is my
Okay, very good. นัดระหว่างนี้เดี๋ยว take attendance อีกรอบแล้วกันจะได้ดูว่าโอเคครับ
this is my data. So I put it in a table form to see which columns that I will be using, and I use the column debtor, which is the customer names, and also the
What is this data again? Sorry.
data is a general ledger of a company that shows how many items are sold.
Say again. I'm losing you a little bit. This is
like a general ledger that shows like which items are sold.
Items sold.
Yes, in a company.
To a company. Okay.
Like so the
Can you widen your thing a little bit? Good. Okay. So this is the customer ID, right? Or debtor? Debtor.
Yes, the debtor is the ID of the customers.
So let's backtrack a little bit. This belongs to what? A bank or a lender or a mortgage or what?
No, a company selling products, safety products.
Okay, selling 60 products. So debtor would be like receivable, debt in that sense, right? It's not borrowing. It's not a loan, right?
Yes.
Okay, so sales receivable. Okay, good. Your reference, blah blah blah. So Rojana Industrial Park has to pay you 455 baht on that date.
The items are here.
Okay. You rotate. Okay, so this is sales tally. Okay, yeah. Gotcha. Okay,ครับ.
So I selected the debtor column, which the numbers vary from 500 here to like 400,000 and like 8 million. So I separated the data into 3 variables. And I also
data debtor. So that's amount, right? This is in amount, so you can see that a lot of money.
This is like a nominal scale for each name. Like 515 is this.
I don't see where data debtor field is. Where's the data debtor field? Data where?
What?
Select data debtor where number. What does the hashtag refer to? That is data debtor, right? And data debtor. Oh, column 2. Oh, I see it. Okay.
Yes.
Sorry. Okay. So this is just ID, right?
Yes, because the number has like 500 and like 8 million and like 400,000. So I have to like separate them into 3 variables.
What's the meaning? Like less than
Like-
500 is a company or something like that?
No, because like all of these are companies. So, and like it's the numbers range a lot. So I have to like separate it because if not, the whole histogram only shows like this much and like I can't see anything from it. So I have to separate it to like make it more detailed. Like this histogram shows that from, like for example, ID 505.
Yes, I understand that. But what is the meaning? What's the meaning of that column?
Oh, it's just like the ID of the vector.
Why are you analyzing the histogram of ID?
Because I want to see like which items are sold together frequently. So if I see which debtor buys which items together like that. Does that make sense?
I don't understand yet. So I don't understand what's the significance. Is there a significance of the debtor ID?
To see if they bought the items, which items together.
Yeah, but why do you have to say data debtor 500 versus data debtor? It's just names, right? ID is just name. It doesn't mean anything. Or if your clients have ID less than 500, it's a big customer, high value network. No.
No, I did not do it like that.
Oh, I still understand actually.
Also, should I just use this one instead and don't have to separate them into different variables?
IDs are not. What are you trying to analyze? You're not trying to analyze ID, right?
Yeah.
So basically, there is this column called ID, right?
Yes.
So it's the same thing. So if you're trying to analyze the quantity, why would?
But like then how can I know like which item is sold together to like the same?
Yes, you have to do that. You have to do like a group by customer ID. That's not a question. That's not a question. The question is, why are you separating IDs less than 600 versus ID versus, because ID is not the amount of money, right?
Yes, because there is like so many numbers of the IDs. I just separated to like easier to see for each ID.
Does not seem to make sense because
So
yeah. Doesn't make sense. Yeah, and then you say, okay, and you're trying to do data set, all right? And then you say 24 is something as you trying to predict, okay? Go down a little bit. Okay, and that's a data, that's just distribution of ID that doesn't really help anybody. Go down. Uh-oh. Yeah, this could be, okay, we'll have to maybe chat with you a little bit after class or something afterward, but it doesn't seem to make sense right now, right?
okay.
I mean, I can do distribution of ID. All I can say is that they're different. Okay, let's go. Let's come back to you, and let's come back to you. Okay, let's go to Naya Pak Bundi.
Hi. Okay, let me share my screen. So I'm having a data from kaggle.com and I'm interested in the e-commerce data. So I will looking for the commercial shipping data, which has 12 columns and around 10,000 data for each. And okay, let me share it in the Excel file. Okay. Here is my data. And yeah, so the questions I want to ask professor is I'm interested in like some of these columns, especially the gender, like female and male, that it would like affect or cause the customer rating and customer care calls, like it's relatable and proportional. Yeah, I will focus on this. And also the reach on time, like yes or no, one for yes and zero for no. I want to know the mode of shipment, like airplane flight or ship or road. Three of them would like relate to the time reaching, like on time or not on time. Yeah.
Okay. So it is a supervised learning exercise, right? Supervised machine learning. Okay. And you have this. Can you go back to the Kaggle page? I want to see the data description.
Okay, sure.
Does it say anything?
Yep.
Description: international e-commerce company wants to discover key insight from customer database. ID, warehouse block, customer calls, reach time if the where one indicates the product are not reached. Okay, so you might in this case, I think there's no intended target per se because they just want a general insight, right? So it could be that don't restrict yourself to just supervised learning. I mean, it's not obvious from here that their primary objective is to predict reach in time or predict weight in grams. I mean, you know what I mean? They might be interested in how different data groups. Okay, so you notice the keyword here. So discover key insight from customer database, right? So again, you're trying to understand your customer. Okay, so that seemed to me, first of all, like a general exercise in maybe even unsupervised clustering. Okay, so you're trying to find out what kind of data do you have different cluster from your groups? Do you have different theme, different niches, and so forth? And so that would be like an unsupervised. You know, don't just do supervised learning. Supervised learning would jump out at you that this is something they want to do because they want to predict the price of milk future in 3 months' time or something. Okay, if they want to discover insight, then it's like if you want to make a supervised learning problem, you have to decide what's your y, what's your x, right? So that tells you right away that there isn't an immediate business case for predicting y. Is there any y that immediately drives something, right? For example, if y is demand, then obviously that has impact on the bottom line, has impact on your production planning and all that. And this reach in time, well, what else do you do with it? Maybe it's a measure of customer satisfaction or something. Or I don't think you should immediately jump to supervised learning. That's what I'm saying. Okay.
Okay.
So maybe there's some clustering analysis you can do. But again, if you want to do it as a supervised learning, then you have to follow through that pipeline. You know, this separate into training, validation, testing, or in sample, out sample, and so forth. Okay, and a lot of your data is categorical, I think. Okay, which means it's either nominal or ordinal scales. If you use If you use Python, you have to probably do some kind of hot coding. And Mathematica will I think do pre-processing for you. So that's not a problem. But don't restrict yourself to supervised learning because they want to have key insight. This is like really fun thing because it's not an object, it's not a contest where you say, I want to predict Y given X, build me the best training machine learning algorithm that has the highest accuracy. This is sort of like, I have a whole bunch of values. Tell me something about it. Okay, so it seems to me that you should start thinking about unsupervised formulation first before you jump to supervised learning.
Okay.
Okay.
So may I ask like one question?
You can ask more than one.
Oh, okay. So I think can I use like Python instead of Mathematica?
Yes, of course.
Yeah, so
You
we'll
have to do all the one hot and all that yourself, I think. But yeah, you're
Okay.
more than welcome to it.
Okay, sure. So I would like to use like Matplotlib and like NumPy and Pandas. Would it be okay, right?
If you're using Python, chances are you will use Pandas.
Okay,ค่ะ.
Okay, let's say it's the main way of handling tabular data in Python. Okay, is Pandas. Okay. NumPy is sort of like doing matrix calculation. You need that. Sometimes you don't even. Okay. You still need to do algorithm, unsupervised learning, supervised learning. So something along the line of scikit-learn, you probably have to use that. Okay. And of course, Matplotlib. By the way, if you're going to Python, there are nicer visualization package built on top of Matplotlib, right? It's like a big family, and Bokeh or Seaborn, a lot nicer and perhaps even easier to use than Matplotlib. They're all built on top of Matplotlib, most of them. Okay? But anyway.
Okay. I will dig deeper then.
Okay, go ahead. Okay, let's go to so you're gonna use Python and okay. Let's go to Pongsathorn, yeah? Pongsathorn. Pichayakon. Pongsathorn ครับ
I
understand that. Yeah.
I have to go before Pongsathorn because I have to leave for the class at 4 p.m. sharp. Thank you.
Okay, that. So this would be who? Papachon. What's it? Okay, Papachon. Good, okay, go on.
Okay. So my project is basically about the pH of the water.
pH balance, okay.
Okay,
I remember reading this.
Yeah. So the background story is my family has a drinking water factory. So, and there are a lot of times that our pH gathered from the water aren't like very according to the to the regulations, and it's very tricky to understand about pH because there are a lot of factors involved in pH. Yeah, in the pH of the bottled water. So what I did was I went and asked for the data from the Grom Utu of Thailand. So I'm gonna share the screen right now.
Good.
So you can see the screen, right?
Yep, go ahead.
All right. So for the two columns of my data,
I can't see.
Okay. Sorry. Is it bigger? Is it bigger yet now? Okay. Thank you. So the pH of the water and the TDS is gathered from the lab of my company for each day. So, but as you can see, it is called like a day because I couldn't get every single day data because the lab closes on Sunday. And all of this column of the weather is from Grom Utu. So yeah. So
what's TDS? Just curious. What's the stand for? TDS?
TDS is total dissolved solid.
Oh, okay. So
Yeah,
measure impurity or something?
it's not exactly impurity. It's more like how many substances are in that particular bottle of water. Yeah, but I wouldn't say impurity because most of them are minerals.
I see. Gotcha. So this would be more like supervised learning, right?
Yep.
How many days worth of data have you got?
So sadly, I only have 120 days worth of data. It's actually 135 now because I managed to find more.
Okay, right. So you remember today we talked about this in sample, out sample, and do this K-fold validation,
Yeah,
right?
yeah.
So I would over you do that and explore the algorithm. In terms of to chances are you may not need to scale your data. You can try different thing. Going back to the lecture points a little bit about scaling. Scaling data is good because it sort of like puts all the variable on an equal amount of movement. Okay, so the model sort of like works easier, right? It works on easier. It works on relationship between variable as opposed to absolute movement. But if you're using decision tree or any kind of machine learning, up to a point, it can adjust for it. A neural network starts out with all the weight nearly zero, but at some point it's going to adjust for it. So if say x5 is in units of thousands and x2 is units of tens, over time the weight will adjust for it. But it's much easier for the model to converge if you pre-standardize it. Okay, but if you pre-standardize it, when you come back and make the prediction, you have to reverse the process to get back at the original values. So up to you. Try a few things. Okay.
I actually have a quick question, ครับอาจารย์
Go ahead.
So at first I was planning on using the predict command in Mathematica to do the
Regression, yeah.
Yeah, do the regression, but it turns out that I'm not sure about the method of linear regression of the Mathematica. Is it like enter or stepwise or forward or backwards? So I'm not sure if I could use Mathematica for the.
You want to use linear regression?
Yeah.
I would imagine that your problem is probably not a linear one. So I would not restrict yourself to just linear regression. Okay. Linear regression is a very easy to understand and ubiquitous, but to use it, it's easy to use linear regression, but to use it properly, you actually have to do a lot of tests before you do it, right? In other words, yes, you can immediately say, build me a linear regression model on this data, but the linear regression data itself is based on a lot of assumptions, linearity, no multi-collinearity between data set. So, don't go for linear regression just because it looks simple. If you want to do a professional project, you actually have to do a lot more work to prove that you can use linear regression. You see what I mean? Because linear regression is simple, it's the best under the circumstances that you're talking about a linear mapping from X to Y with white noise. So you have to prove that beforehand. You see what I mean? So don't be eager to use linear regression. Try different methods. And some method would be, and each learning method has different parameters. With linear regression, it's obvious that you have 10 input, right? With decision tree, you can vary along the line of, say, decision tree depth, maximal depth of 5, of 2, random forest. So there are meta parameters. It's a lot more fun to play with. And when you have this kind of analysis between the in sample and out sample, then you can start to see how different models behave differently, right? Chances are, if you fit linear model, you will get to that high bias and low variance situation where you get equally poor fit between in sample and out sample. Now, if you play with something else, it may be trickier. It may get really good fit in sample, a really bad out sample. So you don't want that either. But play around with it, okay? Play around with it. After all, hey, this is your family business. You want to do a good job.
Thank you ครับอาจารย์
And maybe you can turn it into a tool, so that your plan manager can just upload the data and rerun for each day or whatever. Okay, good. Okay, so you have to go. Very good, Dija. Next, we go back to whom? Pongsathorn, right or no?
Yes, I'll
Okay,
start.
ครับ Pongsathorn ครับ You're up.
Okay,ครับ. So previously I worked on waste generation based on demographic data, but since the data sets were to be from government data, the ones that has access to were very small and difficult to use. Generally, they are in PDF format, which really sucked. So I decided to change my idea to LinkedIn post reception prediction. Since I have a personal goal to write more LinkedIn posts, I figured it would be fun to come up with my own formula of good posts. This is to be done with supervised learning. So the idea is word choices always matter when writing or even communicating in general. So I plan to create a model to predict LinkedIn post reception, which is to be measured with reaction counts such as likes or celebrating and all that. And comment count, the model will consider the words used, for example, word rarity, word count, sentence length, as well as hashtag count and the author's follower count. These are the key ones.
You use the word given. Do you mean that you're using authors follows count as an input variable, or you are controlling for author follows count? When you're controlling for something, that means given that this is the same, you analyze other factors. If you're using it as a variable, then this is variable.
So I'll be using the author follower count as variable. When I say given, I mean given the data that is available to me, which is the author follower count. Yes.
Okay. Yeah. So don't use the word given. Usually, when you say given, it means it's controlling for something.
Okay.
Okay.
I'll
good.
be working on that. So these are the key ones that I'll be working with, but during the process, I think more will come up, and this is one of the things I'm still unsure about. Like, when should I stop thinking about the data? Like, how do I know if the inputs are enough?
You know what?
With this information, I know that I'll be coming up with some more, inputs like columns for my model. Like for contents, I can think of word length, right? Or word rarity, sentence length, maybe phrasing, how they phrase the words, how they do all that. But when do I know that I should stop thinking about that, start working on the actual model?
Well, I guess I would say go right away. You know how you know that there is a change in model development paradigm. It's already been changed. It used to be what's called waterfall, where you do complete specification of this beautiful, gigantic problem, and then you just do it one shot. Well, now you do what's called agile project management. So you do things in loop, in prototype. And when you do this, it means that, you already got started with one set of data, right? Go ahead and build the model and come back, right? So it's not irreversible. So it's not, when should I stop because I can't come back? No, I would say if you think you've got something in the bag, right? You got a decent set of data, go ahead and run it and then come back. Of course, you can say enhance more data set. So yeah, right now I would say that if you already got something going, go ahead and start building the model, go carry all the way to the end of analysis. And it's going to tell you if you've done a good job or if you need something or if model is completely miserable and you have to go to a new data set. Okay. The last thing you want to do is wait until the last week to run the model and then find out that, the model is not giving anything. I have to revise the whole data input set. That would be very dangerous. Okay. So go ahead.
Okay.
So the operative word is pause. Don't stop, just pause. Go, come back.
Okay. I'll definitely keep that in mind. So how I got the data sets at first, I tried to use the LinkedIn API, but I soon realized that the API is mainly for human resourcing. So I decided to find out one on Kaggle instead, and I found one. One point I realized is that this means LinkedIn posts are analyzed less than other social media platform posts. So I think that's a plus for novelty. The top one is the data set I got from Kaggle, and the bottom one is the one that I prepped and plan to work on more. And here's my rough estimate of how I'll be segregating the data for training and testing, but I'm still unsure if I should do this or you have any expert opinion about the numbers I have right now.
Sorry, so you got rows, sensible training data set. Now, each row is a complete embedded text or one tweet or whatever, I don't know.
It will look
LinkedIn.
something like this, like the top one.
I can't actually see. Hold on. Let me go a little bit. Group Nicholas. Okay,
wait,
so it's one sentence. I think each input's in sentence.
Oh no, it's the whole post. Like each row is the whole post. Yes.
So has it been summarized, or you have to do the summarization as well?
Oh yes, I will have to do a summarization as well. But I generally will just extract meaningful
I think
words.
you got plenty.
Okay,
Okay. Again, you can always do this K4, right? So you know this 8,000, especially it's not a time series. Time series, sometimes you want to make sure that the testing is to the nearest closest to the present. But this is not a time series. Presumably, you're not treating it as a time series. You're just treating it as individual standalone posting. So yeah, you can do K4 validation easily. Okay.
And this is just the example of how I'll be going about the problem. There'll be like word extraction and getting rid of the stop words, and then do some word frequency stuff. Yeah, that's about
why is pitch a stop word? Just curious.
Oh, it's not a stop word, but the pitch is not a stop word. So stop word is like
okay.
2 9
Okay, fine. So and okay, good. Yeah, I see the top. I see. Okay, sorry. I went to pitch my project. Period. It was fun. Okay, good. Okay. Over follow count, processing count, reaction. Okay. Is reaction ordinal? Does it?
Ooh, yes, it should be ordinal, but I think I'll find a way to differentiate between different types of reactions. Maybe give them like a bunch of scores, something like that.
Okay. I mean, it's completely up to you. You can make it, you can have even your own scheme of say ratio of positive to negative reaction. I mean, this is to an extent up to your imagination as well, right? How you create a statistics that represent. So you can say, number of if the number of reaction is the name of the game, then you don't even care if it's a negative. Sometimes you just have to say positive net of negative or whatever. Okay. So play along with that. There's no reason why you should just have one bucket to play with. Okay, but seems like you've done a pretty good exploration, and yeah, go ahead. Don't wait for a huge data set. Okay, just go and come back if you get more. Okay, very good. I like this. This is good.
Thank you.
Okay, so we go to go to who? We go to Taya, right? Taya. Bunbandansu.
She had to go now, so maybe skip her.
Okay. Nicha Ratta Nuampon. Nicha. Okay, got you. Go.
Okay, can you see my screen?
Parkinson.
Yes.
Oh, good.
So at first I have to give a reference to the Kaggle. This one is the Parkinson disease detection.
Very good.
And data is collected from the Parkinson, the people who have Parkinson disease and the people who don't, and what they can detect from. They put people to a test which is called something about the voice, because one of the symptoms is the Parkinson will talk slower and some like fluctuation in the voice pitches, maybe something like that. So
are
they
you
have,
working with audio data, or has all these statistics been derived from voice recording? So you don't have to do the audio processing.
right.
The latter, right?
Mm-hmm.
Okay. So it's all numerical now. Okay, it starts with audio recording, but it went through some kind of audio voice and analysis, and then comparison into statistics. Correct?
Yep.
Okay. Good.
And these are some. The columns is about 24 columns. Okay, we can go back here.
This looks good.
Yes, and then I will try to clean the data first.
Yeah.
So it will contain only the stuff that I want, because the original one, it will include status column, which is tell us about the people who got one is who has Parkinson disease, and the 0 is who don't have it.
Okay.
So I remove this one, and I also remove the name too. So it become like this. So it's a pure data now. So we can do the analysis now. I use
Train test. Okay, fine. XGBoost classifier. Okay.
Yes, I use XGBoost classifier instead of support vector machine, because I think this is more appropriate for the data.
Try something else too. I mean, you're using what library? Scikit-learn.
Yeah.
Okay. So random forest, certainly, right? But okay, let's see what you got for.
And then we got a prediction for that. It turned out to be, the accuracy is about 94%. And after that is some of my little experiment to do more fun about that.
94. Can I look at the confusion matrix?
You mean this one?
Confusion matrix, the rectangle thing.
Maybe not.
Okay. How many positive cases as a percentage? What's a percentage positive?
The percentage of the.
Yeah, true positive.
The number of the positive people. I forgot to. It's about 47.
Out of how many?
47.
Out of how many people?
Out of 195.
Okay, so it's not complete. It's not very imbalanced, right? That's what you have to be careful, right? Yeah. So you do the. Remember that as a reference, I use Mathematica's classifier measurement, and that has all these things, cross entropy or whatever. But mainly the thing that it has to produce is the AUC, right? Area under the curve, ROC plot, confusion matrix, which scikit-learn has all that. I think you just have to find the name for it yourself. Okay. So I would use, again, for everybody, even though you're using Python, I use classifier measurements reference page and predictor measurement reference page as a baseline suggestion what you need to have, right? And then you have to look up the name. Not but your TA might be able to help you with this, like what is the scikit-learn equivalent of classifier measurement object, or if you have to do different plots, okay? But it's already in there. It's all in there, okay? But you don't want to just present numbers at the end. It should be graphical plots.
Right.
Okay,ครับ. And again, you can do K4 validation and whatnot. Good, very good,ครับ. And again, from today, you can go on and do SHAP analysis. So that will give you, what actually influenced your model. This is for example, if you think about it, if you have a Parkinson's diagnostic, right? That means that you go to hospital, it takes all this, half a day's worth of measurement, right? But if you did this and you did a SHAP analysis, which is what we talked about today, and luckily, it turns out that only 2 variables matters, maybe something like a frequency or something. Then you can think of making that into an app, because an app can probably take a very crude, quick level. Okay, so it's not all the problems are like that. See, this is opportunity that comes with the data. Some data, if you have 10 variables, you need 8 of them to even get close to be able to predict. Okay, sometimes you start with 8 and turns out that you only need 2 of them, and 2 of them can be measured by using a voice recorder on an app. Then you can make an app for detecting Parkinson. You see what I mean? So the opportunity comes from analysis. Good. Okay,ครับ. Let's go to Shinglin, please.
Hi.
Hi, Kai.
Let me share my screen. Oh my God, can you see this? Okay. This is the data set that I'll be using. It's about chess games and the results. So
Okay.
there are like around 20,059 rows, and
These are tournaments.
wait.
These are tournaments, right?
Yeah. And there are information such as like the number of turns, the winner color, the ratings, the opening names, and those. Okay, so I kind of started the report a little, but I'm like waiting for the approval. So I'm planning to demonstrate interactive visualization tools and statistical analysis, such as the prediction of using supervised machine learning. So I want to find possible findings, such as, is there any patterns or correlations or any strategies that I can implement, and also explain the use of Mathematica, built-in and user-defined data types, as well as analysis and visualizations of data. So I imported these statistics from Kaggle that got the information from a chess game website called Lichess. Yeah. So it includes the information of interval scale, ratio scale, and nominal scale. And the goals of this analysis is basic probability calculation practices, as well as big data calculations, which include like the average number of turns, the percentage of game won by each color, or the rating, as well as like the common or rarest winning status, the correlation recommendations, as well as the strategies. Okay. And this is my first attempt. Okay, so I imported the data and made it into table forms, calculated the length, and did some first 300 values of some topics, such as the number of turns, their mean, maximum, and minimum, the white ratings, the black ratings, the opening moves, and use counts to find the times that the numbers repeat, and plot it in histogram, as well as a normal.
What's a turn? Sorry, just curious. What's a turn?
Number of turns each player did per game.
Turn, just how many moves? Or no? What's a turn? What's the difference between moves and turn?
Um, oh, I'm not sure. I'm not. I'll make sure I know the difference.
Okay.
Okay.
Curious.
Yeah, and
Wow.
I did the same with other things like opening moves,
Okay.
vibrating and stuff. And in the end, I show the differences between the two colors with list line plot, and that's it for now.
Okay. Okay, so you can do again visualization. That's also very good. Okay, and the insight that you can get from it, some kind of if there's a pattern. So yeah, definitely. Chess is one of those things where it has well-established tradition. You can literally, follow different style and so forth, and maybe make a count of, are you more likely to say, you can ask some complicated question that ties in different aspects, like maybe a young players more likely to use Queen's Gambit as the opening move, then that sort of thing, and what's most likely to be the twists and turns and different strategies and so forth. Okay.
Professor, do you have any recommendation on like what kind of graph I can use to show the differences and the correlations?
Well, I mean, in terms of correlation, you have to decide first on again, you did a good job of identifying the number scales, right? So obviously things like a scatter plot and whatnot is good for interval or ratio scale. Now, if you have something that is more hierarchical, maybe like chess strategies, I think it is in a hierarchy. I'm not quite sure. Like opening moves, they have like a standard move. They have, there's a variation. For example, there's Queen's Gambit with this variation, with that variation. So what you might be able to do is introduce a graph plot, a layered graph plot. You know how that looks like a bit like a tree. Looks like a tree, right? But that's sort of like think of genealogy plot. Like this is a family of opening moves. This is a family of defense. That sort of thing. And then you can overlay that with success rate or something like that. So yeah, it can be a very interesting. You can have your own website that shows a very good infographics on chess statistics, right? And people who are let's say not that confident in their ability to play chess may say, well, I'm going against somebody who's rated a little bit higher, and historically you can see that when you are outranked by 2 layers, 2 tiers, usually you can beat them with this and that, whatever. This is a high risk. So, and you can do all kind of stuff. You can make your own statistics even that doing this is a risky move for such and such setting, and how much does risk pay off and so forth. So I really look forward to playing around with this. I don't really have much insight into the game of chess, unfortunately. Maybe I can put you in touch with my son. He's very much into chess, but yeah, I'm certainly not a real player. Good, very good.
Thank you.
I like this. This is very interesting. Okay, Kap. Let's go to Techika.
Hello ค่ะอาจารย์
Hello ค่ะสวัสดีค่ะ
I will share my screen. So the data that I
Your
show,
happiness report. Very good.
so the data that I shows is called the World Happiness Data. It is the rank of the countries based on the happiness score. For the content of this report, the data of the happiness score and the ranking is from Kaggle. The data has 150 columns, including all the countries. The columns are estimated based on the 6 factors: economic, production, social support like freedom, absence of corruption, and generosity. So for this project, I will visualize all the countries' happiness score, compare with social support, health life expectancy, and freedom to make life choices. This is to identify the rank of the countries based on the happiness score. And then after I know the rank, I will use this information to see what country has the most and least happiness ranking in each category. In order to know this, I will use the minimum and maximum to find out. After that, I would do research on what category makes this specific country the happiest or less happy country. So I am wondering if I can use other data to support this data.
Okay, you're not trying to predict happiness score, right?
No, I'm
Okay,
trying
because
to,
it's a formula, right? It is a formula. It's actually, I think it's published, World Happiness Score. In other words, you have all kind of metrics, social metrics. I don't know, in this case, how many of them? 20 columns. Presumably, 19 of them are measurements, and the final score is a scoring, right?
Mhm.
Now, what you should do, first of all, obviously, the most obvious question when people read about this project would say, hey, how is happiness report calculated? Now, you're not trying to repeat the calculation. Like there was a student last class that was trying to predict the electricity price, right? Electricity bill, but that is a formula. So I said, well, you can't do that because it's already a formula. Likewise, you're not trying to predict the happiness score because it is a formula. But you should start with that. You should start with that because that gives us the concept of happiness. Now you can look at the structure of the function and say, well, wait a minute, if happiness can be added together from 19 statistics, maybe different countries can be equally happy in two different ways, right? So maybe, rich but lonely, or, that sort of thing, poor but, good. So there's like a isoquant line. I don't know if you know what I mean. Isoquant means it's the same level. You can get to the same level of happiness through different combinations. Okay, so that's interesting. You can do that. I think what you would like to do at some point would be dimensionality reduction exercise, because what you would like is to put countries that are close together along the 19 metrics. You see what I mean? And then you can say, okay, how are they represented in a reduced dimension, like 2 dimension? So you can use like a self-organized feature map. You can use vector autoencoder or something like that. Okay, so dimensionality reduction would be useful, TSNE, something like that, right? And then you can color code them according to actual value of happiness. So yeah, it's a lot of interactive visualization, and you can think of this as based on a very static, very dry data set. You make it interactive. So like the COVID thing that I share with you guys, right? It's a flat file, but you make it something interactive. You can make a cobweb or a radar plot. You can choose different things. You can compare your country because you only care about your country. You want to compare your country versus neighboring country. You want to compare your country versus a country with similar GDP. Okay, oh, we have the same GDP, but we are happier or something like that. Okay, good. Okay, so you're on your way. You're on your way. So this is the world happiness. It's on Keiko.
Pardon?
Where'd you get this data?
Oh, Keiko.
Okay, good.
Thank you.
Is there an opening challenge to that? Sometimes Keiko would say, challenge is to create a visualization. Challenge is to predict who is happier. What's the challenge of this one? Because it seems more recording.
It said, it don't really say anything. It just said what it is, like what
okay.
is data.
Go play with it. Okay, fine.
Okay.
So it's not, it doesn't have a challenge statement to it. That's fine. Some Keiko is a proper competition. Some Keiko is just a repository. So this is more like a repository flavor. Let me just go with one more and let me count 1, 2, 3. I have 10 more that we can cover next class. Sorry. So I think yeah, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, let's have Sunat.
สวัสดีค่ะ
Sunatcha. Okay, so let's have Sunatcha, and then we'll call it a day, and then next week we start with Jenjira. Okay,ครับ
Okay, let me share the screen. Okay, so this is my data set. So it is about the customer behavior inside on e-commerce. I get it from the Kaggle, and it has 225 rows and 18 columns. My plan is to find the relationship between this data, like the gender, age, shopping time, to see the, it's a relation.
This is not the same one as your friends, right? It's a different one?
No, not the same one.
Okay,ครับ. Okay, which product, utility device, mouse, keyboard. What happened to, how do you deal with when column J is empty? What do you do?
This is like the scale. So I just choose the thing that I want to make the relationship. Like as I have said that I want to use the gender, age, and see which type of product that they buy and make the relationship and like the classification on that.
Okay, let me make a general comment. It applies to you and everybody. If you have 10 different variables, okay, don't make a judgment, a prejudgment, say, I'm going to use age or gender, right? It should be experiment. It should be experiment. So the only thing that you should quote unquote choose would be your target. Whereas your input, you shouldn't be choosing. You should be trying as many as you can. You see what I mean? The model, again, using chat, for example, may say something like, once I put in gender, marital, occupation, blah, 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 it turns out some variable is more important than the other. You should not be choosing, data is precious. When somebody gives you 10 columns, don't say, I'm just going to use column 2 and 3. Okay? Okay, it shouldn't be, you should never do that. You should never do that. That should be a limitation, right? And that's why I was asking about empty cell, because sometimes you don't use a column because it's a lot of empty cell and you don't know what to deal with it and so forth. But, maybe you can fill empty cell with null or unspecified or generic, right? And then you can say, you can have different categories. You have utility device, mouse, keypad, headphone, and the blank could be something like unspecified. And then you can say, well, what is it most likely to, correlation of unspecified? How many data points do you have, by the way? Should be huge.
It have 225 rows.
Is that it?
Yeah.
That's kind of weird. This kind of data should be large. I mean, it's almost like, look at the timestamp. It varies by minute. You should have like 225 just on one day. Go down to the bottom. Yeah. Done that many days, huh? Oh. Okay. Where'd you get this data set? Sorry.
Kaggle.
Okay, so I'll give you the, okay.
Or you just I have to find more, or is it this one?
You don't have to, but I'm just surprised that usually for this kind of shopping data, you have many rows. Okay, usually you have thousands of rows. I'm really surprised that Keiko would, unless this is just a particular company that doesn't want to share very many. That's kind of weird. Yeah, I'm really surprised. I'm just surprised. I'm not saying don't use this, but certainly play around with it. But definitely don't restrict yourself to just sex. I mean, right?
Okay.
Okay. Remember that insight I was telling you about? You want to know that, even though you make a good prediction, sex may be good for predicting product A, but useless for product B or something like that. Okay. So never do that. Never throw away data just because you don't feel like having too many columns. Okay.
อาจารย์ค่ะ I would like to ask about is it okay if I use the classification thing like the cluster or unsupervised learning?
Yes, you can do whatever you like. Do what you like. Yeah, certainly it's how you formulate. Okay, it's just that when you're working with Kaggle, sometimes they would say that this literally is a prediction challenge, right? Remember, Kaggle can be you can open up a Kaggle page and say, like just now, it's a data set of world happiness. Play with it what you like. Okay, however you like it, fine. Or it could be a company that say, I want to predict customer demand. These are my 80 input variable. Please build a prediction model. That is definitely a supervised learning. In this case, we'll look at the Kaggle statement. Is there a challenge associated with it? Or is it just say, well, this is a data, you play with it. So, you know, just make sure it's sensible, right? It would be silly if you go to a page that is a Kaggle challenge and say, the purpose of this data challenge is to see who has the best prediction model predicting Y given all this X. And you say, well, I'm just going to do cluster unsupervised clustering. You see what I mean? So yeah, to an extent, you determine your problem, but certainly just make it reasonable. Okay.
Okay. All right.
Okay. So you okay? So it seems like not so bad. Again, don't try to. I see two tendencies. One tendency is just want to make complicated model and not proceed until you have all of the data and so forth. On the other hand, some students just have very simple data and want to make it even smaller. No, don't do that. Don't do that. Okay. Just think of data as something precious, something you have to pay for to do your analysis. So if you get everything, use as much as you can. That would be the idea. Okay, Kap. So sorry for going a little bit over time, but we'll pick up the last class, I guess, next. Basically, you know, this thing that I was telling you about filtering and machine learning. Well, in next class, what's going to happen is we're going to learn a lot of machine learning that actually tunes or train the filtered parameter. And that's the success of a lot of modern technology you see next class. And then we'll leave some time for 10 students that are left, okay? Okay, Kap. I will, yeah, I would try to make, I would try to insist somehow that as much as you can, you incorporate the SHAP plot, which is, again, is readily available in your analysis if you can. So, okay. Other than that, I send you the text file, so you have that. So you got everything. Okay. So I'll see you guys next week. Okay. And there should be 10 more of you, and I'll make sure to cover everybody. Okay, Kap. So with that, I'll see you guys.
อาจารย์ค่ะ
ค่ะ
ของศิวรัตน์อะค่ะที่บอกว่าให้แก้
แรกใช่ไหมลูก
ใช่ค่ะ คือให้ทำ
คือนี้ค่ะ คือ ID เนี่ยมันไม่ควรจะเป็น predict มันเป็น completely เขาเรียก nominal scale ถูกไหมมันเป็นแค่ name เราไม่ได้พยายามจะหาตัวแปรอะไรเราไม่ได้คือและ data มันก็ไม่ได้ใหญ่ขนาดที่ว่ายูไม่สามารถดีลกับทุกคนได้ก็เลยต้องดีลทีละแบบนะอันนั้นเป็นเรื่องที่
มี 20,000 เยอะมากเลยอะค่ะแบบ
20,000 จิ๊บจ้อยลูกหนูจ๋า 20,000 จิ๊บจ้อย anything you can open in an Excel is จิ๊บจ้อย
งั้นก็คือไม่ต้องแยกเลยใช่ไหมคะ
ตั้งก่อนคือจริงๆนะถ้าสมมุติว่าคือตอนแรกเนี่ยบอกว่ามันแยกก็เลยนึกว่ามันเป็นวิธีที่จะ designate ภายในเช่นถ้าตัวเลข membership ต่ำกว่า600เนี่ยเป็น VIP ถ้าตัวเลขหลักพันขึ้นมาเนี่ยเป็นพวก mass อะไรเงี้ยนั่นค่อยมีเหตุผลไงจ๊ะที่จะแบ่งเข้าใจไหมคะแต่ถ้าจะแบ่งเพียงเพราะว่าเฮ้ยมันต้อง 20,000 is nothing 20,000 is nothing จ้ะนะคะไปโฟกัสonตัวแปรที่อยู่ฝั่งขวาสิ นะมันมีตัวแปรตั้งเยอะแยะที่เปิดมาเมื่อกี้นะครับ analyze ตรงนั้นนะครับ ID เนี่ยก็เพื่อจะบอกว่าอะไรแล้วบอกว่า product คือจริงๆแล้วเนี่ยพอทำเป็น data set แล้วเราก็ทำอีก data set เรา group by ได้ group by ID แล้วก็ใส่ว่าซื้ออะไรบ้างนะครับโอเคไหมหนูจะใช้ Python หรือหนูจะใช้ Mathematica คะ
Mathematica ค่ะ
ถ้า Mathematica เนี่ยไอตัวอย่างที่ส่งลิงก์ไปเนี่ยที่เป็นเรื่องโควิดอะค่ะไปดูนะตรงนั้นเนี่ยนะมันเป็น Data ที่เป็นประเทศนะพอเป็นประเทศเสร็จเนี่ยสมมุติว่ามันเป็นประเทศแล้วก็เป็นโควิด2 ปีที่ผ่านมาสมมุติเราอยากจะรู้ว่าเป็นสถิติเนี่ยก็เราก็กรุ๊ป by ประเทศแล้วก็ไปดู average หรือว่า total หรืออะไรอย่างเงี้ยนะทำได้อันนั้นเนี่ยก็คือเวลาทำเป็น data set มันทำได้นะครับ
ถ้าทำเป็นเหมือนบาสเกตที่ตอนนั้นเคยทำในคลาส
ใช่หรือจะทำเป็นบาสเกตไงแต่ว่าบาสเกตเนี่ยถ้าทำบาสเกตก็ทำได้เลยไม่มีใครห้ามแต่เมื่อกี้เหมือนกับว่าหนูอยากจะกรุ๊ปก่อนเข้าใจไหมอยากจะ consolidate by customer ก่อนคือบาสเกตเนี่ยมันเป็น abstract notion บาสเกตคือการซื้อ1 ครั้งก็ได้หรือบาสเกตคือการซื้อทุกครั้งของคนนี้ถ้าบาสเกตคือการซื้อ1 ครั้งก็ไม่ต้องทำอะไรไม่ต้องกรุ๊ปบายเลยใช้ทั้ง 20,000 คอลัมน์ไปเลย 20,000 แถวไปเลยแต่ถ้าสมมติว่า 20,000 แถวเนี่ยมันเป็นลูกค้า 5,000 คนและบาสเกตของหนูเนี่ยหมายถึงการซื้อโดยลูกค้า1 คนนั่นคือบาสเกตอยู่ก็ต้องกรุ๊ปบายถูกไหมมันแล้วแต่ objective ของ analysis ไงคะถูกไหมอันนี้คิดเอาเองอันนี้คิดได้อยากจะทำอะไรก็ได้ไม่ว่านะครับจะทำเป็นกรุ๊ป by ดู by คน by day หรือไม่ดู by คนไม่ by day ก็มั่วเลยหมดกันทุกบาสเกตเลยไม่ว่าจะเช้าสายบ่ายเย็นเสาร์อาทิตย์จันทร์อังคารโดยในกอในขอในคอทุกอัน individual basket การซื้อ1 บิลคือ1 basket นี่ก็ใช้ไปหมดเลย20,000 แถวอะไรก็ว่าไปโอเคแต่ถ้าเราจะกรุ๊ป by ก่อนก็กรุ๊ป by ก็ไม่ว่ากันได้เหมือนกันเข้าใจไหมครับแต่ถ้ากรุ๊ป by มัน tricky นิดนึงอยู่ก็ต้องทำเป็นเนี่ยใช้ data set เป็นตัว organize นะครับ
โอเคค่ะ
ได้ค่ะนะครับมีอะไรก็ไลน์มาก่อนก็ได้นะถ้าผมไม่อ่านอะไรก็เดี๋ยวพี่นัทเขามาจะดูก็จะมาเตือนเองว่ามีเด็กถามมาอะไรเงี้ยนะครับลิสถามด้วยนะจ๊ะ
ขอบคุณค่ะ
ครับผมโอเค so I'll see you guys นะครับ anybody else ไม่มีนะลูกโอเคครับจ้าสวัสดีครับสวัสดีครับ
ขอบคุณค่ะ
ขอบคุณค่ะ
Thank you ค่ะอาจารย์ and stay safe นะคะ
คุณรักครับ you do ครับ be safe
Good luck too ค่ะ
ค่ะอาจารย์